Hello everyone, welcome back to Let's Crack JEE in English, the channel of Unacademy. Let me check my voice, audio, video first. Alright, so here is my profile. I am Jeetendra Dixit. I did my BTech from IIT Kanpur and I have been mentoring IIT-JEE aspirants for last 11 years. So I teach mathematics and we were doing complex numbers, geometry of complex numbers. And today we'll continue that. We did two locus in last session, circle and perpendicular bisector. And we'll see other locus of Z in argand plane with the given equation today. But before we begin, let me tell you about the Unacademy subscription. So as you know, Unacademy is India's largest online learning platform. Hello, Subhashri. Very good afternoon. So you can have two types of subscription, either plus subscription you can buy or iconic subscription. So if you get plus subscription, then you get access to daily live classes of all the educators. All right, all the educators, and you can follow educators of your choice. Live tests and quizzes, all these courses are well structured, and this is unlimited access you get when you buy plus subscription. And these are the subscription charges. You can buy it for 12 months, 24 months, 6, 3 and 1 month. 12 months charges are 38,500, and after 10% discount you'll have to pay only 34,650. Use this code JEET1 to get 10% discount in all the subscriptions. All right, now this is iconic subscription, in which you get all the benefits of plus, and other than that you get a personal coach, all right, who will guide you throughout your preparation for all top exams. Yes, in evening also I have class, Subhashri. In evening I have I'll continue continuity. Okay, so continuity class will be in the evening, and test analysis will also be done in a personalized manner. Okay, personalized feedback will be given you to improve your time management and exam approach. Your study planner will be customized to you, and bi-weekly reviews will be given to you and that will highlight your progress. Okay, these are the subscription charges for iconic. 56,000 for 2 years. Time is same, 7 to 8. Hello Deva, Biswas. All right, and for 2 years it is 86,000 and you'll get 10% discount. Use the same code. How are you guys? Subshri and Deva. Unacademy's learning app you can download from Play Store. This is the app, and you can attend special classes. Special classes are free. You don't need to take any subscription for that. You can attend unlimited special classes on the platform. Okay, so every day many educators are taking special classes. I also take special classes, doubt solving classes, basically in maths, mostly at 8:30. Time might be different. Okay, now let's continue complex geometry. So as I told you that when you write argument of, in previous session I have told you this, argument of z1 minus z2 is what? All right, you already have, very good. See, this is z1 and this is z2, all right, and say this is the real axis. All right, in which class are you in? Class 12th or 11th? Deva Biswas, are you in class 11th or 12th? Then argument of z1 minus z2 is nothing but this angle which a line joining z2 and z1 makes with real axis, right? So if you make this this will be the direction will be from z2 to z1. Okay, this direction. So direction matters. Okay. So this angle is basically argument of z2 minus z1 minus z1 minus z2. Okay. If you write z2 minus z1, then direction will be opposite. Direction will be this, and then pi will be added to this angle, right? Pi plus. So today first locus, what we are going to do is basically based on this. So z is a variable complex number. Z is a variable complex number, all right, and satisfies argument of z minus z1, all right, is equal to theta. Theta and z1 are fixed. Theta is a real number. Theta is a real number and constant, and z1 is a fixed complex number, all right, fixed complex number. Then what is locus of z? The locus of z we need to figure out. Okay, so that is our question, locus of z. So see how to do it. So you make this first of all Argand plane, real axis and imaginary axis, all right, and take any point anywhere, first, second, third, fourth quadrant, your z1. So I have chosen z1 here. Okay, doesn't matter. And then you see argument of z minus z1 is fixed. It is theta. So if I take say theta is say 60 degree, for example. So if I take z here, then you can see z minus z1, this vector will make angle 60 degree, right? To make this angle 60 degree, okay, I have chosen my z in such a way that line joining z and z1 is inclined and at an angle of 60 degree. Okay, I'm taking theta is equal to 60 just to understand this. Okay, so or you can say theta is an acute angle. So it diagram will look like this. All right. Now in this diagram, for this particular position of z, argument of z minus z1 is theta. But now see how this z will move on Argand plane. If I take z here, okay, other than this line, then you can see z minus z1 argument will be different now. This angle will be basically increased more than theta. And if I take z here, then argument of line joining or vector joining z and z1 will be less than theta. Okay, so that means you can take z anywhere other than this line. If you take z anywhere on this line, like here or here, then direction will remain same. Direction of line joining z1 and z will remain same. Okay, so this line, this ray, we call it ray because it is starting from z1 and it will be upwards only according to this diagram. Okay, you can't take z here, otherwise direction will be different, right? Then argument will be theta plus pi in this case, right? So it is a ray starting from z1. It is a ray starting from z1, this ray. Okay, and go up to infinity. That is the locus. For example, let me give you an example. If I ask you to plot locus of argument of z minus iota is equal to pi by 3, first example. Second, argument of z minus iota is equal to pi by 2, and third example, argument of z minus iota is equal to 2 pi by 3. All right. Okay, so first let's plot these three, then we will plot other examples also. So this is a real and imaginary axes. So real and imaginary axis. Okay, here is your iota, this is your iota. All right, so first line which you need to plot is z minus I. So vector joining z minus I, direction will be from I to z. Okay, should be inclined at an angle of pi by 3. Okay, so at an angle of pi by 3, you need this. See, I am drawing this line horizontal, okay, parallel to real axis, so that I can easily measure my angle with this line. So this angle is pi by 3, 60 degree. So on this ray, we call it ray, or you can say a line, okay, Z will lie. So Z will lie on any, I mean, you can take Z anywhere on this line, okay. So that will be the direction, and this is the argument. This angle is pi by 3. This angle should be pi by 3. So this is the locus. Have you got this point? And this iota will be excluded, okay. Z cannot be equal to iota, so that point will be excluded. Let me put open here. So you can put open interval, okay. Yeah. So that is a ray emerging. Can you write the Cartesian equation of this line? I mean, the equation of this line whose part is this ray. So this ray, if you want to write a relation in x and y, I'll write it. Say your z is x plus iy, okay? Then x and y will satisfy. We can write a Cartesian relation. So just write the equation of this line. Equation of this line is y minus, this line is passing through 0, 1, right? So y minus 1 is equal to tan theta, so tan 60, which is root 3 into x minus 0, so x. So you'll get this, y is equal to root 3 x plus 1, but this will give you, this equation will give you complete line, even this portion of line, which is left side of y-axis, but this is not the part of locus. So to exclude it, you can further apply one condition. What is that condition? In this particular case, you can see that x is positive, okay? X is positive on this part, for this part, okay? For this part, x is positive, or you can apply condition on y also. Y is more than 1, right? So either apply condition on x or on y. So after applying that, now this will represent your locus only, right? Your locus. Your locus means this ray. So first you have written the Cartesian equation of this complete line which contains this ray. Then you have applied one more condition, okay, which will represent only that part of the line which is our locus. All right. So in this way you can write the locus precisely. Now let's discuss the second one. So second one, I'll use some other color. So now this point is same, the point from where this ray is going to emerge, but this will be at an angle of pi by 2 with horizontal. So this point I have kept same. So angle is pi by 2. That means this line is going to be vertical, right? So this ray is vertical. This is your ray. Okay. This is your ray. It's blue color. Okay. This is your ray. So Z will lie on this. Now Z will lie on this. Okay. That is the direction. You can see this angle is pi by 2. Now to write this equation, this is x is equal to 0. X is equal to 0, right? Cartesian equation, simple y-axis. And y is more than 1. Y is more than 1. So that will represent only this part of the y-axis, imaginary axis. Now the third one. The third one is, again, it is ray emerging from iota, but now it will be inclined at an angle of 2 pi by 3. So 2 pi by 3, it's all right. Now just change the angle. So 2 pi by 3 will be here. It is just the reflection of yellow ray about y-axis, okay? So that is the ray. Now this is the line, okay? And what is the equation of this line? The equation of this line is going to be y. Y is equal to, now this angle is going to be tan 120, which is minus root 3x plus 1, all right? Same point. And now in this case, x is going to be less than 0, right? Now, x was greater than 0 for that yellow line and for this. So this was your first locus, second locus, and this is your third locus. So can you see the rays? So as angle varies, this ray will vary. Now I'll give you some more examples, okay? So slightly more complex examples. So example 4. is argument of z minus 3 plus 4i um, z minus 3 minus 4i is equal to minus pi by 3. So angle can be negative also. So see how to tackle it. Now I'll give you fifth example. Argument of, now it is 1 minus z, all right, is equal to pi by 3. Okay, that is 1 minus z now. And example 6 is argument of 2z minus 1, 2z minus 4 minus 2 iota is equal to, say, pi, 2 pi by 3. Yeah, perfect. So now you need to plot these three. I'll plot the organ plane here. Okay, so let's plot the first one, fourth one. At this point you can write z minus 3 plus 4i. Okay, so z1 is where with 3 comma 4. So 3 comma 4 is somewhere here. 3 comma 4. This is your 3 comma 4. Now z is inclined at an angle of pi minus pi by 3. So how did you get this minus angle? When you measure angle in anti-clockwise direction, it is considered as positive angle. When you measure your angle in clockwise direction, clockwise, okay, then it is considered as negative. All right. So minus pi by 3 means you need to measure your angle in clockwise. So pi by 3 is in this direction. All right. This is pi by 3. So ray will start from this point. So z lies on this line. Okay, this is your z, locus of z. How to write the equation? Let's write the equation. So this line is emerging from y minus 4 is equal to tan of minus pi by 3. Take this angle as it is, and x minus 3. So if you simplify, it is going to be y is equal to minus root 3x, and this is going to be plus 3 root 3 plus 4. All right, that. And further you can apply condition, because this is the equation of complete line. You need to exclude the line, part of line which is before 3 comma 4. Okay, so you can apply x is more than 3, or you can also write y is less than 3, right? You can say y is less than 4. Line is going down, so y will decrease, right? And it is going right side, so x will increase. X will be more than 3, or you can put condition y also. Not necessarily you need to put both the conditions. You could to take minus 2 common. An argument of minus 2 will also be pi, so there won't be any change. Argument of minus 2 or argument of minus 3 will remain same. They will be pi only. All right. Just a moment. Let me check my connection. This 2 pi, measure this angle 2 pi by 3 in clockwise direction. Okay, so that is your line. If you want to write the equation, you can write y minus 0 is equal to tan 2 pi by 3, tan of minus 2 pi by 3, sorry, into x minus 1. So it is going to be y is equal to root 3x minus root 3. All right. And now what is the condition on x? And further, to write only this part of the line, you need to apply condition on x and y. So x will be less than 1, right? Less than 1. You can see x line, this line is going towards negative x, right? I mean left side of x axis. So x will decrease, right? X will decrease, even y will decrease. You can apply condition on y also. If you apply the condition on y, it should be y less than 0, right? Less than 0. So now these two equations simultaneously will represent only this line. So I hope you got it. Okay, so now let's do the third one. Sixth one. So in this you can see coefficient of z is 2, so you can take this common. So argument of 2 you can separate. Argument of 2 now let me use which color I want used so far. This one. This is argument of 2, and if you take 2 common, this is going to be divided by 2 here, right? So it is plus argument of z minus 2 minus iota, right, is equal to 2 pi by 3. This argument of 2 will become 0. Argument of any positive real number is 0. Plus you'll get argument of z minus argument of z minus 2 plus iota, alright, is going to be 2 pi by 3. So now you need to take this point 2 comma 1. So 2 comma 1 is say this is 1, this is 2, 2 comma 1 is somewhere here. Let's take it randomly. This is the point, say 2 comma 1. Alright, and you need to measure angle. Yeah, you need to make a line at an angle of 2 pi by 3 with the x-axis. So line will be like this, 2 pi by 3. Positive side, so this ray will go in this side at an angle of 2 pi by 3 starting from this point, which is 2 comma 1. Yeah, 2 comma 1. Okay, this point is 2 comma 1. Do not compare it with any other point. Okay, position wise we have taken it randomly. Okay, so 2 comma 1, and yes, now equation, Cartesian equation. So Cartesian equation will be y minus 1 is equal to tan 2 pi by 3, which is tan 2 pi by 3 is minus root 3 into x minus 2. All right, and what is the condition on x? X will be less than 2, right? Because line is going towards left side. So this is the sixth one. So if you got the rays, how to plot them, I hope it would be clear. All types of examples we have done. Now you can plot any such locus of z. All right. Now I'll give you one example to solve. Find z which satisfy argument of z minus 2 iota is equal to pi by 3 and mod of z minus is equal to mod of z minus 6 iota. All right, so z satisfies two equations. Okay, two equations are given. You need to find z. I've already discussed both types of locus. Got any answer? No? Alright, then I'll do it. Okay, so let's plot it. So your first locus is a ray emerging from 2 iota. So this is your 2 iota and it will be inclined at an angle of pi by 3. So this ray will, let's plot it with white color. So this will be at an angle of pi by 3. So this is the locus, right? You can write the equation. We'll see if required we can write the equation pi by 3, or we can find it using geometry also. Ratnakar Roth, you have asked, sir, please take revision class of coordinate geometry. It has used weightage in mains. Ratnakar Roth. Okay. Sir, in this last 3 months except previous year, that else should practice for maths for JEE mains. I mean, what are you asking? First, you're asking me to take revision class of coordinate geometry. I'm taking a revision class of parabola soon. That will be probably by the end of no. It is planned on Saturday. So Saturday I'll be taking a revision class of parabola. After that I'll take ellipse and hyperbola also. So you can attend that class, all right? Ratnakar. Got it? So this is the locus. Saturday, 12 p.m. and 3 p.m. I'll be taking revision of complete parabola, standard parabola, and properties. Now second is basically second curve is perpendicular bisector of the line joining 6 iota and origin. So 6 iota and origin, right? So second locus is this. Will pass through 3 iota, right? This is 3 iota, perpendicular bisector. So this is going to be your Z. So this is the horizontal line, y is equal to 3 line. So obviously coordinate of this point will be, y coordinate of this point will be 3. You just need x coordinate. And x coordinate is nothing but this distance, right? Which you can find easily using geometry. See, this point was 2. This point was 2 iota. So what is this distance? This distance is 1. Okay, 1. Let's mark these points A, B, and C. We need C. AB we have got. AB is 1. Okay, AB is 1. So AB is 1. Let me change the color. This is 1. Okay, and we know this angle. This angle is 30 degree. Okay, this angle is 30 degree. So you can apply tan 30. Tan 30 is equal to this x upon 1. So x is nothing but 1 by root 3. All right. So you got x. So your z is this is your z. Z is 1 by root 3 plus 3 iota. So this is the z which will satisfy both the equations. Okay, the ray and this perpendicular bisector, they will intersect at this point. Are you getting this? Have you got this point? All right. All right. Now let me tell you another locus, which is basically putting inequality. So argument of z minus z1 is less than or equal to theta 2 and greater than or equal to theta 1. Okay, theta 1, theta 2 can be positive, negative. All right, so two numbers are given and your argument should be between these two. So what you need to do is all right. So let's continue. Okay, so in this case, what we need to do is, then one argument, it is greater than minus pi by 6, so you need to plot a ray which is at an angle of minus pi by 3, so minus pi by 6. So you need to measure this angle pi by 6 in anti-clockwise direction, and one at 2 pi by 3. Okay, so one angle at 2 pi by 3, so 2 pi by 3 is like this. So total this angle is actually 150, right? Yeah. So this is another ray. So here z should be between these two. Okay, so that is the locus. That is the locus of z. Getting this? Between these two rays. So between these two rays, your z will lie. Are you getting this point? I hope it is clear. I'll give you one more example. Find the area represented by z, where z satisfies z minus 4 minus 3 iota is less than or equal to 4, and argument of z minus 4 minus 3 iota is less than or equal to pi by 3 and greater than or equal to wait a minute, less than or equal to pi by 6 and greater than or equal to minus pi by 4. Okay, that's one. Okay, now you need to find the area of the region where z lies. Okay, so locus of z. So locus of z should be a region, right? So it will be a region, and you need to find the area of that region. Alright, so let's plot it. I hope you have got any answer. Have you got some answer? If you're getting it, then write in the comment box. Alright. No answers? Okay, so we'll plot the circle. Vamsi, Subhashri, anyone? 4, 3 is the center and radius is 4, 4, 3. So if you make this circle, This is a circle, right? Interior of a circle. So if you make this circle, the first locus is just the circle of radius 4. So it will touch y-axis, right? But it will not touch x-axis. Anyways, that is not our concern. So here is the center, 4, 3. Now you need to plot these two rays. So we have just discussed this, right? So 4, 3, which is center only. From this you need to make two rays. One is at an angle of this horizontal line. So from this, one is at an angle of pi by 4 in clockwise direction, this ray, okay, and another ray will emerge at an angle of pi by 6, okay, pi by 6. This angle is pi by 6, this angle is pi by 4. So total, if you add these two angles, pi by 6 plus pi by 4. So this is the z satisfied by, okay, second equation, and outside also, outside this, right? But from first equation it should be inside the circle. So for z which satisfies both will be inside the circle and between these two yellow lines. So that will be basically this region, right? Only this outside circle will not be, z will not be outside the circle, okay? So you need to find, so you can see this is nothing but a sector basically, right? This is a sector. This is a sector whose radius is 4, and what is this angle theta? Theta is this pi by 6 plus pi by 4. So that is going to be 12 and 2 plus 3, 5 pi by 12, right? So it is going to be 5 pi by 12. Okay, 5 pi by 12. So theta. So area of this area is equal to, what is the formula of sector? 1 by 2 theta. Now 1 by 2 theta into r square. So 1 by 2 theta is 5 pi by 12 divided by r square. So that is 4 square. All right. You can see. So 8. You can cancel the term, simplify it. So it is going to be 3. So 10 pi by 3, I think, right? Yeah. 10 pi by 3 unit square unit. Same thing. So this was the answer. I hope you have got it. Now let's do one more locus. Now next locus is Z1 and Z2 are two fixed complex numbers and Z is a variable complex number, and Z satisfies Z minus Z1 upon Z minus Z2. Argument of this is going to be theta. All right. So what is C? What is Z? What is the region represented by Z? See, this is Argand plane. I'm not plotting x and y axis, or you can plot it here. Doesn't matter. This is your x axis, real axis. All right. So say this is your Z1, all right, and this is your Z2, Z1 and Z2. Do you remember one thing, that if two fixed points subtend, I'll make it here. If two fixed points subtend a variable fixed angle, two fixed points obtain a fixed angle at a variable point, okay? Say he's saying that A and B are two fixed points, and P is a variable point, and this angle is fixed, say 60 degree, all right? Then locus of P, what will be the locus of P? Locus of P will be an arc, right? Do you know that? If A and B are on an arc or on a circle, then they subtend a fixed angle, okay, on this arc. Do you know that? This angle will be fixed, it will be 60 only. It will be 60 only. All these angles are equal. And if you take any point outside this, then this angle will be less than, this angle will be less than 60. And if you take a point inside the circle, then this will be more than 60, okay? So these are the only points where this AB subtends 60 degree, right? But you can make one more arc. If you take the reflection, then same arc will be here only, here also. So basically two arcs, two major arcs, major and minor will depend on the angle, right? So two major arcs you can make in this case, here also, right? Because there's no direction, these are not vectors, so this angle is 60 degree here also, right? So this is also the locus. So two circles you can plot, and these major arcs, first major arc is the part of this circle, and second major arc is part of this circle, all right? So you can draw two circles passing through A and B, okay, of certain radius. Radius will be fixed, that will depend on the angle as well as on the positions of AB, okay? So that will be a fixed circle. So on this arc, major arc, AB is subtending a fixed angle. But let's come back to previous case. Here, now we know what is this written. This is written argument of Z minus Z1 minus argument of Z minus Z2. So we know argument of Z minus Z1 is basically this angle, which this is say Z1 and this is Z, which this vector joining Z minus Z1 makes with real axis. This angle is say theta 1, and this is Z2. So Z minus Z2 is basically this angle, right? This angle theta 2. So this is nothing but theta 1 minus theta 2, right? Theta 1 minus theta 2. So if you know this angle is nothing but theta 1 minus theta 2, right? This angle, if you complete this triangle, you can see this angle is going to be Z theta 1 minus theta 2, all right? So if you take Z here, see, with this diagram it will be clear. I'll make this diagram again. See, this is the vector joining Z and Z1. This is the vector joining Z and, that was Z and Z2, now this is Z and Z1, okay? If you draw a horizontal line here, okay, you can see, I'll remove this line, I'll explain it again. Well, slightly confusing here. I'll explain it again. One thing you need to understand, then this is the difference of arguments of line joining Z minus Z1 and Z minus Z2, okay? So you can see this is the argument, If I am calling this theta 1 and this is theta 2, then theta 1 minus theta 2 is theta, all right? That is fixed. So this angle is basically theta 1, now you can see that, right? And if I extend it further, then this angle is theta 2, and clearly you can see this angle is going to be theta 1 minus theta 2. That's what I was talking about. This angle is theta 1 minus theta 2. That means theta, okay? So you can say कि Z1 and Z2 is basically Z1, or you can say line joining Z1 and Z2 is subtending an angle of theta on Z, all right? And Z is constant, okay, in this case. So this will be the, Z will move on the arc. I won't say major or minor because that will depend on the angle theta. So Z will lie on the arc passing through Z1 and Z2, okay? Whether it is major or minor, that will depend on the theta. But like in the previous example I have given it here, will you get another arc also, which is, I mean, in this case, below Z1 minus, below the line Z, line joining Z1 and Z2? Let's see, let's check. Okay, so here also if you join this, I'm taking Z now downwards below this line, joining Z1 and Z2. So Z is here, this is Z minus Z1, and this now the second line is Z minus Z2. All right, so this is Z minus Z2 vector, and this is Z minus Z1 vector. All right, this direction basically. We are focusing on the direction. Now see, this will be the argument of Z minus Z2, and this will be the argument of Z minus Z1. So which one is greater? Now your theta 2 is greater than theta 1, right? So theta 1 minus theta 2 will be basically negative. So yes, in this, on this arc, if you take Z on this arc, which is downwards, then magnitude wise this angle will be theta, but it is actually minus theta, right? Because now these are vectors, okay? So you can't just measure this angle geometrically. Geometrically this angle is theta only, right? So Z1 and Z2 is subtending this angle, angle on Z. Z1 and Z2 is making this, this angle Z1, Z2, Z and Z1 is theta only, but this argument, difference of arguments is not theta. Difference of argument is minus theta on this circle. If you take Z on this arc, okay, so that means this is not the part of locus. So out of these two arcs, which geometrically you can see angle is constant, theta is constant, where theta is constant. So out of these two arcs, only one will be the part of locus, okay? Only one will be the part of locus. So this is the part of this equation, okay? So this equation represents this arc. So whether it will be up or down, circle above the line joining or segment joining Z1 and Z2, it will be above this segment or below this segment, this arc, major or minor, that you have to check, okay, in the question. So I'll give you some examples, and we can check in these examples whether which particular arc will be our answer. So let's take one example. If I give you argument of Z minus iota divided by Z minus 1 is equal to, say, pi by 3, all right? So angle is acute, that means it is going to be a major arc, all right? So you can see it's slightly difficult to understand, but once you got the point what I'm trying to explain, then it's easy to figure it out. Okay, see, one point Z1 is iota, Z2 is 1, okay? So it is written that argument of, first simplified, Z minus iota, which is theta 1, minus argument of Z minus 1, which is, say, theta 2, is equal to pi by 3. So that means theta 1 minus theta 2 is equal to pi by 3, okay? So we need to take the difference of directions of Z minus iota and Z minus 1, okay? So this is your iota and this is your 1. Now I'll plot it with some other color, say white. So Z minus, let's take Z here. So what I was saying is either arc will be above this, that means this side, above in first quadrant, you can say, or below, that means origin side, okay, side of the origin. So either this will be your answer. Okay, I'm plotting it with dotted curve. Either this will be your arc, or arc will be like this. These two arcs are of exactly same size, okay, same size. That means this chord joining iota and 1, these two circles are these two arcs are of exactly same size, okay, same size. Circles will be of equal radius. So this chord is chord of both the arcs, common chord, you can say. So this A and B, let's name them. So AB will subtend equal angle on these arcs, okay? This angle is pi by 3, as well as this angle is also pi by 3, all right? Now we need to check which one is plus pi by 3. Either this will be plus pi by 3 or this will be plus pi by 3. Okay, so that depends on the directions. So first let's check any one. So if you check this one, it is easy to check this one generally. So which direction is z minus iota? Z minus iota is this direction, and z minus 1 is this direction. So you can see argument of this is parallel to x-axis. Okay, so argument of z x-axis is here. Okay, this is x-axis. So argument of z minus 1 is basically theta 2. So this is theta 2 and this is theta 1. So basically in this case theta 2 is greater than theta 1. Okay, so basically theta 1 minus theta 2 will be minus pi by 3. Okay, but we need plus pi by 3. So that means this is not a arc. Now let's check this one also. By the way, now you don't need to check. This will certainly be your answer, but still if you want to check, then let's check it. Now which direction is z minus iota? This is z minus iota. Clearly you can see it is now inclined at an angle which is more than theta. Okay, wait a minute. Z minus 1. Okay, now let's check. So plot a line which is parallel to x-axis and check the angle. Okay, so this angle is theta 1 and this angle is theta 2, right? This angle is theta 2. So clearly theta 1 minus theta 2, this angle is theta 1 minus theta 2. So this angle is also theta 1 minus theta 2 is equal to plus pi by 3. Okay, so yes, now this is your answer. Okay, this is your answer. This arc is your answer. So I hope now you have got it. How to figure out which one is your answer, the arc above the chord or below the chord. All right, so you need to check this angle like I was checking in this question. Okay, now point arises that how to find the center of these circles, center and radius and all. Okay, so I'll tell you how to find center and radius. Okay, so this point was 1, this point was 1, 0, and this point was 0, 1. Okay, and this angle was pi by 3. Let's use it. So we are getting this arc. Now question is to find center, radius. So let's make a big diagram. Okay, this point was 0, 1, A, and this point is B, 1, 0. What is known to us? We know that this angle is pi by 3. That's what is known. This is the only thing which we know apart from coordinates of A and B. This angle is 60 degree. So using this, because that's a major arc, so we know that angle subtended by this chord at the circumference is half of the angle subtended by this chord at the center, right? So if I take center somewhere here, there is not origin. Okay, so center somewhere here, then this will be the radius, this is center, then this angle will be 120, right? If you subtend a perpendicular, you know this will bisect this chord, so this point is C. So by the way, what is this BC distance? Half of AB. AB is basically root 2. AB is equal to root 2. So you can write BC. BC is 1 by root 2. All right, BC is 1 by root 2. Now wait a minute, let me check. All right. So this BC is 1 by root 2. Okay, this distance is 1 by root 2. Now you can use this geometry. This angle is going to be 60 degree and you can find radius easily. Okay, so radius here is tan, not tan, sine theta. Sine theta you can use, yeah, sine theta you can use. So sine of 60 degree is going to be 1 by root 2 perpendicular upon hypotenuse radius. So r is going to be, this is root 3 by 2. So it is going to be 2 by root 3 into root 2. So your radius is coming out to be root of 2 by 3. All right. So in this way you can find the radius. Now you've got the radius. Now another point arises how to find center. So to find center, you'll have to use this symmetric form of line or distance form. See, can you find the slope of this line? Slope of this blue line chord AB is basically -1. So what will be the slope of OC? This is O and this is C. Slope of OC is going to be m is equal to -1. Okay, it's very simple. And you can write the coordinates of C also 1 by 2 comma 1 by 2, right? So I'm going to use distance form of line. So we need OC. OC is basically, OC you can find is R cos 60. So R cos 60 is R by 2. So it is OC is basically 1 by root 6. Okay. How did I get this? R cos 60 is root 2 by root 3 and cos 60 is 1 by 2. Okay. So it is R by 1 by root 6. R cos 60 OC. So we have got OC. OC is 1 by root 6. Okay. Because tan theta, this is what? Tan theta. Tan theta. So we need to write sin theta cos theta. I'm going to use h plus r cos theta and k plus r sin theta. So sin theta is equal to this plus 1, I suppose. Yeah. Sin theta is 1 by root 2 and cos theta is also 1 by root 2. So how to write this? See, on a line, if this point is h comma k, I'm just revising you. And this line is inclined at an angle of theta with x-axis. And you need to take this point x comma y, which is at a distance of r units above, okay, above this point h comma k. Then x is basically h plus r cos theta and y is equal to k plus r sin theta. That was the formula we did in straight lines, okay. And if point is below h comma k, then it will be h minus r cos theta and y will be k minus r sin theta, right? So because you are going below this, okay, we already know the direction, okay. So we are going below this point C. So coordinates of O, let's write this x comma y. So x is equal to h is this 1 by 2, this point is h comma k, okay. We have got everything, h comma k, sin theta cos theta and r is 1 by root 6. So h minus r is 1 by root 6, cos theta is 1 by root 2, all right. And y is equal to k, which is 1 by 2, minus r sin theta. So it is 1 by root 6 into 1 by root 2. Although this OC was basically part of x, y is equal to x line, so you could use that particular point to find O in this particular case. But I was telling you the generalized method, which you can apply in any other curve, all right. Actually, this line was y is equal to x line, okay. So it was easy to find y coordinates of this 0, 0, because you can take this x comma x and you can apply distance formula as well in this case, all right. But this is a better method. This method you can apply in any any position of the circle, all right. So I hope you're getting it. So in this way we have got center, you have got radius of the circle. So now you know everything, okay, everything of the circle. Slightly lengthy, yeah. But if you're good in this writing distance form, slopes and everything and geometry, then you can do it quickly. But if you're not good in this, thank you, Anuj. All right, so now we will continue. Now I'll continue tomorrow with some more points on the locus of Z, all right. So tomorrow I'll continue with complex geometry, all right. So by then, take care and thank you very much for watching this. Like my videos if you're enjoying watching them, all right, and subscribe the channel. Thank you very much. Thank you, Anuj.